Welcome everybody to the Multisim video, and we're going to talk about the standalone program that you can download through the class if you still have access to the Education Edition. Otherwise, we're going to also talk about Multisim Live, which is what National Instruments has done so that you can actually work these circuits in a browser. Okay, you don't even need the standalone program. So that's what we're going to do. And first up is the actual Multisim program. So if you are following along here, you would want to go ahead and open up Multisim now. Okay. So I have version 14.0, and I believe the Education Edition that you may or may not have downloaded is 14 as well. Excuse me. Everything 14 and up is pretty similar though. So this is the board, so to speak, and yours may be defaulted to something else. I've had this program for a couple years on this laptop anyway, so I've changed how it looks. So when you start up, it may look like this. So all I did was right-click out here, Properties, and then I went to the Workspace tab, and you can also have it do this thing where it shows the grid. So you can see the little points where you can make connections, okay? I don't need that. I think it looks a little bit cleaner, at least for what I do, because I'm teaching this. I like it to be just white back here, okay? So the whole idea behind this is that you can construct circuits using whatever values you want, whatever sources you want, however many sources you want. You have access to, excuse me, thousands and thousands and thousands of resistors and capacitors and inductors and diodes and LEDs and all kinds of different stuff that, for the majority of your classes, you may not even use everything that Multisim has, even if you go all the way to a bachelor's degree in electrical engineering. So it's a very powerful program, and it's an industry standard and an industry leader in terms of circuit simulation, analog circuit simulation. It does digital as well, okay? So, so what I'm going to do is just go through the process of adding a few components to the board here, and then show you how to wire it up, how to simulate it, and then how to put some instruments on it so that you can gauge, what the voltage is, what the current is, all that good stuff. So, the easiest way to do this is come up here to Place. Okay, so Place, and then the top one there is Component, right? Now, so the shortcut for that on your, if you like keyboard shortcuts, is Control W. Okay, so like when you do Allen Bradley software, the PLC software, it's the same thing. Okay, they have a lot of Control R and that kind of thing, keyboard shortcuts. So if you're into that, I will try to mention them as we go along, because I know some people like to do that. Okay. So if you don't, just go Place Component, and here we are. So in this initial default list, here is every component that's in Multisim, right? All the groups, all the families. So you want to dial down into your specific group so you don't have to sift through all this. So one way is to, up here, is to start typing and use it as a search bar, which I shouldn't have just done that because now it's going to get clogged up. Use it as a search bar and search for whatever component you want. The easiest way, though, is just to know what group your component is in. All right. So the first three are going to be the ones that we use the most. And let's see, is there anything else? We may use the indicators. I'll show you how to use the indicators. But really, the sources, basic, and diodes. So I'm going to go to sources first. Okay. So now you can see this has been reduced down to just these, what, seven or eight families here. And we will not use any of the ones underneath, all right? The only one we will use is power sources, okay? Now this further refines it down, so now we're into sources, power sources, and now you can see we have a much, much shorter list. So for the 2/3 of this class, we'll be using the DC power and the ground. Those are the two things that you'll have to have in every circuit unless we have AC power and ground. Okay, but AC power won't come into the last third of the class. So for almost everything, we want a DC power supply in the circuit. So I select it, and then I click OK. All right, now I can choose anywhere that I want to put it on here, and watch what happens as soon as I click my left button. It takes me right back to the selected component, because it assumes that you just want to get all your components on there at once, and then you can move them around. Okay, and that's what I'm going to do. So I said I need a ground, so I'm going to go ahead and select that. Okay, place it on there. Now I need some resistors. Okay, so now I'm going to come over here to sources. The next one down is called basic, and that's where you have all of your basic components here. Okay, and that includes, if you get about 2/3 of the way down or just over halfway, the resistor, the capacitor, the inductor. Now you'll notice what happens when I click resistor. Here's a list of all of the preloaded component values. That doesn't mean that you have to use these. That's just the ones that they have pre-created, so to speak. Okay, I leave it on the default, which is always 1K, because you can easily change the value. So I just add 1K resistors, however many I need. I'm going to do 3 in this case. So I'm going to go ahead and add all 3. So OK, OK, and OK. All right, I think that's all that I need for now. If you wanted other components, again, here's the capacitor, and it even looks like a capacitor, and you can choose whatever value you want, or you could just add the 1 micro and then change it. And then there's the inductor. Okay, so we will also use diodes, which I'm going to go ahead and show you that now as well. So the next one down is called diodes, and for our purposes, as far as I know, if you just choose diode here, they have the component, like the model number of some of these diodes that are in here. Okay, we will probably just use the virtual diode for Zener and for just a regular silicon diode. Okay, that I think I don't even know if it makes it drop 0.7 volts or not, but anyway, that's where we'll probably use these two for the Zener and for a silicon diode. And then when we come down here to the LED, okay, don't use any of the bars, use these colors down here. Now what I like about this is, let's see, I think it's red. Red is, it takes 1.83 volts to turn it on, a 1.83 volt drop. If I select green, I have a 2.13 volts. So red is the LED that takes the least amount of voltage to turn on. Okay, if you get up here with like blue, that requires almost 3.5 volts to turn on. The infrared, okay, the infrared only requires 1.83. This is the LED that's in your remotes at home. So that little clear domed plastic thing, you can tell which is the business end of your remote control, right? It's got the little notch in there, the little hole, and then it's got that little plastic light. That little plastic light is an infrared LED. And so that's what's operating in your remote control. Right? Then you have, let's see, orange, 2.13, and then yellow, 1.83. So yellow and red. Yellow and red are the two lowest, along with the infrared. But you can see, essentially the way they set this model up is you have to have at least 1.83 volts across this LED when it's hooked up in the schematic for it to operate. And it also gives you an indicator of whether it's on or not. So you can see here to the side, that's yellow. If I pick the green, you can see that there are green LEDs over here, and when they're off, they're just white. And so you can tell when it's on because it will actually activate this. So you can actually see these turn on and off. It's really cool. Okay, I'm going to go ahead and close this because I have all the components I need for my circuit. Now, I'm zooming in here, and the way I'm doing that, and you'll probably find this pretty quickly if you're doing it with a mouse, is that if you roll your mouse scroll, it will automatically zoom in and out. Okay? All right. So usually the way I like to do this, I like to rotate this one over on the right because I like to make a, like a rectangle when I do this. You can make this however you want, okay? If this is a series circuit, I could put them all three right next to each other in series like this, and then, make my wire from here to here, here to here, and then bring the wire down and around. I can do that. That's not a problem. I typically like to space it out, but I'll show you what that looks like if you wanted to wire it up this way. So if you want to connect a wire from a piece to a piece, you can see that as I hover my mouse over any point, any junction, I get that little crosshairs. Okay, and so this is not a click drag. This is a click, move the mouse. You get one 90-degree turn wherever you go. That's it. You get one 90-degree turn. If you need to make more, then you can, wherever you want to pivot, make another click, and then you get one more 90-degree turn. Okay? So it's kind of like an Etch-a-Sketch to some degree. So this is valid, by the way, what I just did. I know that looks ridiculous, but some of you probably don't even know what an Etch-a-Sketch is. Anyway, this is legal, right? Because I'm making a conductor connection from here to here. Okay, now that's not efficient. It looks kind of funny, but that's not efficient. So I'm going to delete that. So I select it and then just hit the delete key. So I'm just going to go straight from here to here. And then click, 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 click. Now this one I'm going to have to make a turn. So click and down. And then about right there I click and I turn up this way and complete the circuit. Okay, so that's one way to do it. I don't like that because it's all crammed together, and if I wanted to put meters up here, they're all going to be on top of each other. Okay, now the last thing to do here is I always connect my ground to the negative terminal of my battery. Right, that's my 0. If you don't have your ground in the circuit, Multisim will not simulate it. So anyway, I haven't changed any component values yet. Let's just run this. How would I run this once I have it complete? Up here, I always call this the play button. You could also use F5 on your keyboard to start it, but I always call this the play button, and it's for run. All right, it's to start the simulation. Essentially, it'll activate the sources. It'll turn them on. If you have a complete circuit down to ground, it will simulate that current flowing. And then it does all the calculations in the background for you. So this is what it looks like without any instruments. So I just hit run. And the only way I would know if this is running or not is there's two visual cues. I guess there's 3. But one of them is the design over here will be blinking. Okay, see how it blinks on and off? I know that that's actively simulating right now. The other place I know that this is simulating is down here in the right-hand corner. Right? You can see how much elapsed time there's been. All right, so it's been running for 15, 16, 17, 18, 19. Okay, so I know that it's simulating based on this down here. The other way I know it's simulating is that up here, the play button is depressed and the stop button is now visible. Okay, but I'm not getting any information here. I don't have any meters set up. All I did was just turn the circuit on. Okay, so I'm going to go ahead and stop. And what I'm going to do is delete the wiring that I have here, and I'm going to rearrange the whole thing to something that I would probably use. So I select the wire and delete it. Select, delete, click, delete, click, delete, click, delete. Okay. I'm going to put my R3 down here, and I'm going to put my R2 over here on the right, but I need to rotate it because I want it to be vertical. So one way to do it is to click it and then right-click and say rotate clockwise or counterclockwise, doesn't matter. But you'll notice here the shortcut is Control R. And so I always select Control R to rotate. Okay, so click, 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 click. I'll stop making those noises on the next circuit. Click, click from this point, click to this point, and add my ground. Okay. Now I have a little bit of room to put my meters in if I would like. So I told you there's a couple different ways that you can measure here, and you see over here on the right this what we call the instrument panel, and this is access to, I would presume hundreds of thousands of dollars probably worth of function generators and meters and oscilloscopes and just pretty much everything that you could ever think of. Logic analyzers, the logic analyzers that I used to calibrate, those were, $30,000. So, we have an access to pretty much any meter that you can think of that would help you analyze a circuit. Okay, so what we're going to focus on is, for one thing, the very, very first one at the top, which you can see there I've got highlighted, and it says multimeter. So go ahead and click that, and you don't have to click and drag, it's just click and then move. So the way that these operate, and part of the why I love Multisim, is it forces you to make a measurement just like you would in the real world. So if this meter is going to measure the voltage on this resistor, then I need to make sure that my positive lead is over here at the high potential and my negative lead is over here at the lower potential, right? Because the voltage drops and the potential here is higher than here because the resistor has to drop some voltage. So when I do my voltage measurements, and I'm going to go ahead and place that now, I need to make sure my positive terminal is always closest to the positive terminal of this battery. Okay, so click over here. So this is just like if I was making this measurement. This is how I would do it. I would have my meter, I would take my positive red lead, put it over here. I would take my negative black lead and put it over here. Okay. Now, in terms of seeing the actual dial, this is just an icon. You have to double click it to bring up the little window. Okay. Now, it is a multimeter, so this does an ammeter function, a voltmeter function. It does resistance measurements, and it also does some dB, some decibels for more AC work, okay, and signals. So we are going to use these three functions: the ammeter, the voltmeter, and the ohm meter. Okay, so right now I'm measuring voltage, so I want to make sure I'm on voltage, and then you select whether you're in AC or in DC. Now this is DC volts. So again, you kind of have to use this just like you would a normal DMM, because you have to select the function and you have to select what type. Now this one is auto ranging, so you don't have to choose the range, so that's nice. But anyway, this is all set up now. Let's look at this. If I have 12 volts and I've got 1K, 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 that's 3K total, which means for one thing, that means that 12 volts divided by 3K gives me 4 milliamps. So I should get 4 milliamps in this circuit. And then because these three are all the same resistance, I should get the same voltage drop on each one. So they're going to split this 12 volts up equally. So I expect to see 4 volts on here. I expect to see 4 volts here and 4 volts here because I have not changed those values yet. So let's go ahead and simulate this and see if I get 4 volts on this 1K. Click run. There we go. Okay, so it's working as expected. Let me go ahead and hit stop. I'm going to go ahead and add a few more of these multimeters. 1, 2. Okay, so that's what. So our meters are roughly 50 some dollars. So there's $150 of meters right there. Okay, so notice how, I could just go ahead and give myself a couple of 90 degrees here to get up here to make this work, but this is just essentially another component, the way that Multisim sees it. So I select that and I can do Control R. All right, so that kind of makes the wiring a little bit nicer if you're worried about that. If you don't mind the squiggly lines, then it doesn't matter. It all works the same. Okay, so now I'm going to double click this one and I want it in DC volts. Very good. And then finally this one, I'm going to Control R, Control R. So I've got it rotated around this way. And I don't really care what the icon on the schematic looks like, because what I'm worried about is the little window that pops out. So it just makes it easier to wire. I guess I can show you what to do if you don't want to do that. So Control R, Control R. I still need to make sure that the positive is on the higher potential. And as we go around here, this node is a higher potential than this one, right? So I'm going to pull this one over here. And yes, you are allowed to cross lines. If there is a connection, you will see a junction like this little circle or like this little circle. There is no junction here, so these two wires are not connected to each other. Okay, so that's a very important distinction. So you can get as crazy as you want with this wiring. I mean, I could do this and then bring it up here. As long as I don't make a junction connection anywhere, I'm allowed to do all of this ridiculousness. And then put it back here. Okay, and if I simulate this, it'll measure 4 volts. There we go. So that looks ridiculous, but it works because all Multisim cares about is that connection. Okay, so I'm gonna get rid of that that whole thing. And so this is why I would just rotate. Just makes it a little bit easier to wire it up. Doesn't really matter how you have it oriented. What matters is reading these things. Okay. All right. So I'm going to go ahead and close this out. I'm going to get rid of all of these connections. I'm going to leave them on here, though. I'm going to move them off to the side. Now what I'm going to do is I'm going to use the magic probes. And the magic probes are, I don't even think they call them that anymore, but in previous versions of Multisim, they were yellow, and we called it the little yellow magic probe because you could just put it on a component or put it in the circuit, and it would just magically tell you what the voltage was at that node and what the current was, even though you didn't have to hook it up like a normal multimeter. Okay, so it's kind of cheating. It's using the fact that this is a software program to figure that stuff out. So first thing I want to show you is the voltage magic probe. So if you just choose the 1 volt meter like this, what it's going to tell you is what the node voltage is. So the node voltage right here, right? The node voltage is always referenced to ground. So if you have your red lead here and you had your black lead on ground, or you had it on this ground, or you had it on another ground, what is that potential at this node compared to ground? You know, -0. The other way to make a voltage measurement on here, I'm going to leave this right there because this thing should measure positive 12 volts because it's connected directly to this positive 12 volt terminal. The other way to make a voltage measurement with the probes is this other one called differential voltage. Now this one works more like a multimeter. Okay, so I can come in here, I place my positive lead first, and then I place my negative lead. So now I'm measuring the voltage potential between here and here. All right, so that's the only difference between node voltage and a component voltage, is where you're referencing your negative lead. A node voltage always references to ground, and we don't have to show that on here. It's just known that a node voltage is always referenced to ground. And if you have a component voltage, then you're referencing the higher potential side to the lower potential side, okay, and doing a subtraction there to find the voltage drop. Okay, so I'm just going to put a couple more of those in here. That's another differential voltage, and another one. And I can move this down here so that's kind of out of the way. All right, I'm going to move this one over, and you can pretty much move all of this, all of the writing and things like that. Okay, so nothing has changed here. I still have the 3 same resistors, so now I should be able to see 4 volts on all of these, just the same. Okay, so there's my 4 volts, 4 volts, 4 volts. Notice my node probe here is referenced to ground, and so I'm touching the positive 12 terminal here. Now, here's the thing. What is this node voltage? Well, if this right here is 12 volts, and I drop 4, that's what it's telling me, I drop 4 here, then that should be 12 minus 4. This node voltage should be 8. The other nice thing about the probes is that while this thing is running, I can come up here and grab a node probe and stick it right there while it's running. There it is. So I have 8 volts here. Okay. Now I have another 4 volt drop, which means this node voltage right here should be 4. So I go grab another probe, stick it on there. I move this down here so it's out of the way. And there we go. I have a node voltage of 4 volts. Okay. So the voltage probes, they can be added at any time. I'm going to go ahead and do all the ammeter stuff next, but it just makes it nice. You don't have to use the multimeter, and you know, I still like using it because I like mimicking what the instruments do. But anyway, I'm going to go ahead and stop this, and now I'm going to go ahead and get rid of all of these probes so we can clean this up. And so now let's talk about, let me come back to here. Everything still looks good on the stream. Always just got to double check myself. Okay, so we have the same circuit set up. I'm not going to change it because we know what the current should be, right? If there's a 4-volt drop across this 1K, that means it has to be 4 milliamps. And the same thing, we have 12 volts and we have 3K. That gives us 4 milliamps. So I'm going to put this multimeter as if I was using it as a regular ammeter. So we know that we have to break the circuit. Now in this little series circuit here, I can do that anywhere. I could do it right here. I could delete it, and I could insert my ammeter in its place. Okay, Control Z, Control Z. It will undo up to 10 commands, by the way, if you want to use Control Z. I could delete right here and insert my ammeter in line with the circuit. Control Z, Control Z. I could do it right here, or I could do it right here. It doesn't matter where I put it. Matter of fact, I could put 3 of these in just to show you it doesn't matter where I put it. So I'm going to go ahead and put it here, one of them here. Delete that. Right? The positive lead has to be closest to the positive terminal of the battery. So I just connect that right here. Remember, the ammeter has to become part of the circuit loop. And so I have to come up here, and now I have to tell it that it's ammeter mode, ammeter function, and I want DC amps. Okay? So let's go ahead and press play. And there we go. There's 4 milliamps. Okay? Now let's go ahead and add another one, just so you can see it over here. Bring this back up. I'm not even going to change its orientation. I'm just going to leave it where it's at. Connect, connect. Okay, now I've got a loop again. I got to make sure that this is in ammeter mode. DC amps. Okay. Oh, and it measures the same thing. Okay, now let's try it down here. And this is oriented, well, just perfect. Come up to here, come up to here. Double click it, make sure it's in ammeter mode, DC amps. All right, so there we go. So we got 3 meters in there, and they all measure the exact same thing. Now, if you happen to have one of these in the wrong function, this is what happens. Okay? So you get funky answers here. Because essentially what happens when this is in in voltmeter mode, is this thing becomes a giant, let's see, I wonder if it's in here. Oh, there we go. Essentially, it's a 1 giga-ohm resistor. So, it's still, you have to think about this. The current still has to pass through the meter to get to these other components, right? So the meter has to have a very, very low resistance when it's in ammeter mode. So you can see that when it's in ammeter mode, it's 10 microamps. That's nothing. That's a short, right? Because we don't want the ammeter to add a bunch of resistance to the circuit. So it has a very, very low resistance. However, when you have it in voltmeter mode, because you're always putting a voltmeter in parallel with a component, you want it to have a very, very high resistance. And so 1 giga-ohm is pretty darn high. However, because I've got this in series and I'm using it like an ammeter, essentially this multimeter became a big 1 giga-ohm resistor. That's why it's taking all the voltage and these are getting none of it. And why you have such a small little current here is because this is a 1 giga-ohm resistor in series. Okay. So I'm going to go ahead and get rid of these. I'm going to get rid of this. And I'll get rid of this. Get rid of this. And I'm just going to connect the circuit back up. And I'm going to go and use the magic probe. So I go ahead and simulate this thing. So while it's running, I come up here and grab an ammeter current probe. Oh, there we go. And you just stick it right on any branch that you want. Boom. Now watch what happens down here. I've got the arrow pointing the opposite direction. So now this time it measures negative. If you need to flip it, just right click and say reverse probe direction. There you go. So the probe direction has to follow where the current is supposed to go. Okay, so there you can see. I could even pull another one up here. Whoop. So they all measure 4 milliamps. Okay, so I'm going to go ahead and delete those. So like I said, the magic probe stuff is cheating. And the multimeter will force you to use it as if it were as if you were doing it in person. Okay. Now, one of the things I just mentioned in the resistance multimeter video is the fact that you can measure the total resistance in a circuit. So I'm going to go ahead and get rid of this source just for a minute, and I'm going to come up here with my multimeter. And because resistors are not polarized, it doesn't really matter what the orientation of this is. It's going to measure the same no matter what, because you can't measure negative resistance. So I'm just going to connect the leads to the circuit. All right, so just like in the video, it's going to measure all of this resistance in series, because in series circuits, that's how we calculate the total resistance. We take all the resistors in the loop and add them together. So what you should see here is that this should measure, if I'm in the ohm meter function, that it should measure 3K total. There we go. Okay, so I can also take a multimeter and come up here and measure an individual resistance. Remember, you cannot have this thing powered when you do it. Okay, so now so what is an ohm meter? The ohm meter is 10. Okay, that's the current. It doesn't have a resistance for that. So because both of these are on at the same time, I'm going to delete that. Now it should work. So there we go. So I'm doing an individual resistance measurement there. If I can delete this part. There we go. So I'm just making the single resistance measurement. It measures 1K. Imagine that. Okay, so let me go ahead and Control Z, Control Z, Control Z, Control Z, Control. Nope, not going to let me go back any farther than that. So I guess it's 10 moves or the last time you did a simulation. And you can use a mix of the probe and the meters if you want to. Let me go ahead and show you the indicators, because that's yet another way that we can do measurements. And these students like sometimes because you don't have to double click to get the meter to come up. Okay, so if we come up here to place component and then we go choose the group of indicators, you can see here we have a few different types of voltmeters, ammeters, and then there's all kinds of this other stuff. There's lamps that'll come on that you can drive. There are probes that you can drive that are different colors to let you know if a node is on or not. And so we're just going to look at the voltmeter and the ammeter. So I'm going to go ahead and grab a voltmeter. And notice that there are 4 different types, and they all kind of look similar. What you're seeing is that the polarity, the orientation of the indicator is what's changing. So here's the voltmeter horizontal. Okay, positive, negative. So red lead, black lead. This is voltmeter horizontal reverse, which is the negative lead is here, black lead, and then red lead. This is the voltmeter vertical, so red lead on top, black lead on bottom, and then voltmeter reverse, black lead on top, red lead on bottom. That's the only difference between them. Same thing for the ammeter. Ammeter horizontal, positive to negative. Ammeter horizontal reverse, now it's negative to positive. Ammeter vertical, right? Red lead, black lead. Vertical reversed, and that's black lead and red lead. So I'm going to go ahead and put a horizontal indicator in here. And I do need to go back and add my source. I have to go back and add my DC power source. Connect this all back up, connect this back up. Now I'm going to use this just like a multimeter around this component and hit play. There we go, so 4 volts. So that's what they like about it, is the fact that you don't have to double click it, and it just, because the display is kind of always on, you can see what it looks like. The only thing is you can't move the little pop-up around. You have to leave it where it sits. Okay? So if I wanted to use another indicator, and maybe the voltmeter vertical, right? So that's going to make an easier measurement over here on the right-hand side, because of the orientation of this resistor. So now I can click. So So again, these are all going to be 4 volts. I'm just showing you that you can use other measuring methods. So I'm going to do one more here, and I'm going to do the horizontal reverse. So place component indicators, and then horizontal reverse. Because now down here, for this resistor, this is a higher potential than this one. And so I need the red lead over here and the black lead over here. There we go, 4 volts, 4 volts, 4 volts. And I guess I'll go ahead and put in the ammeter. And where should I do that? I'm going to move this out and give it some space. So again, you have to place it like a typical ammeter in line. And so I'm going to do the horizontal. Close this. Make my connection here. Make my connection here. So I still have a loop, right? There it is. Boop, boop, boop. And so now it's just going to display the current when I hit go. So there we go, 4 milliamps. Okay. All right, now let's go ahead and start changing some component values. So I'm going to delete all this stuff. Just select and hit the delete key on my keyboard. I'm going to go through the process again because I don't want to move all these around. So I'm going to come up here and say place component, sources, power source. I want a DC power source, and I want a ground. And I also want to go to basic, one underneath it there, and go to resistor, and then just add 3 of these. 1, whoops, 2, and 3, and I'm done. Okay, so I'm going to go ahead and Control R this one, and then move this down here. Okay, so let's say that we are working, just studying maybe for the first exam. And I know that the battery that I'm using is 9 volts, and that's what I'm going to be using the whole semester, okay? Or, you know, whatever your battery size is. Or maybe you have a variable power supply, whatever the case may be. You can change this value at any time. If you double-click on the symbol itself, it brings up the properties for this component. Okay, and then the very first one on here is the DC voltage. So you can change that to whatever you want. I'm going to change it to 9 point. So I think my battery, when loaded down yesterday, was giving me 9.4 volts. Okay, but I'm just going to leave this at 9, just for these purposes. If you want to change these component values, again, the reason I just add the 1K is because you can just quickly double-click this and change it to whatever you want. And it does recognize prefixes. So it recognizes capital M as mega, lowercase k as killa, lowercase m as milli. The U, even though it's technically the Greek letter mu, Multisim uses the letter U as micro, and then nano and pico. Okay, and then also out in front here, I guess, it also recognizes the prefix giga. Okay, so I'm going to make this a 2.2 k ohm resistor because that's a component that I have in my kit. I also have a 5.6 in my kit, so I'm going to use one of those, 5.6 k. And I also have a 1.2, so I'm going to make this a 1.2 k ohm resistor. So there we go. So I just created this, and I can double check myself, you know, by constructing the circuit and double checking my theoretical calculations. But anyway, so I get my calculator out. I do this on paper. You know, I find the total resistance, I find the total current, and then I can find the individual voltage drops, right? So I get all my work done, and I say, I wonder if I got this correct or not. Okay, you can just come in here and start, you know, measure the current. Let me flip this around. You can measure each of the component values. I'm going to do that with a multimeter here and here. And I know these are funky lines. This one I'm going to do with the voltage, the magic probes, this voltage drop. And I guess I'll come up here and say place component indicator, voltmeter horizontal reverse for the bottom. So I'm making 3 voltage measurements using 3 different methods for this, just to show you they can all be done interchangeably. Now, I haven't done the calculation on this. Let me do that real quick. At least for the current. So we have a total resistance here of 2.2K plus 5.6K plus 1.2. That gives it, wow, that worked out nice. I didn't plan that. That worked out to 9K. I was trying to give us a decimal point here, but that's not going to work this time. So anyway, 9K, if you take that into 9 volts, you're going to get 1 milliamp. Okay? So that's what we should expect here. So let's go ahead and run this and see. So there's our current measurement right there, 1 milliamp, as we suspected. And we have, well, since it's 1 milliamp, it makes the voltage drops pretty easy, right? Because 1 milli times 2.2K is going to give you 2.2 volts, right? So there we go, 2.2 volts. This one's 5.6 volts. This one's 1.2. Okay, let me go ahead and stop this. And just for theoretical purposes, I'm going to change this. I'm going to make this, 50 volts, just so we can get some variability here. Now I'm going to simulate it again. So you can see here, this one now drops 12.2 of the total voltage. This one drops 31.1, and this one drops 6.67. Okay, and remember from our KVL discussion, that makes sense because in a series circuit, the highest value resistor, because V equals I times R, the highest value resistor is going to have the highest voltage drop. So I expect this one to have the highest voltage drop and this one to have the lowest voltage drop. Okay? So there we go. So that is how I would do all of my work from here on out in this class. Is I would come up with a circuit, and you can, you have access to all these different I think there may even be some, there's like some name brand, let's see, maybe it's down here, Agilent multimeter, there we go. So this is an actual, it replicates a 34401, which is something we used to calibrate all the time. This is a 6.5 digit multimeter, and you can actually work on wiring up a real Agilent multimeter and interacting as if you were pushing the buttons on the thing, right? So it's got a simulator that's running in the background that's essentially running the Agilent code, and then you can interact with the buttons on here as if it were the $1,500, $2,000 meter that it is, right? So this is one of the industry standards right here, is the 34401. Same thing with there's a Fluke equivalent too that gets used all the time. So anyway, that's pretty detailed, and some people like to use the actual, let's see, here's an Agilent oscope, and so it's got the actual, function control of a regular oscope, right, as if it were hooked up, right? It's got a power button. I can turn it on. So, there's all kinds of cool stuff that's in here, and yeah. You just have to add it on here, and you can add as many as you want, and you don't have to pay extra money. And again, that's the whole point of all of this, is that you're able to simulate all this stuff, change values around very, very quickly, and then re-simulate, right? You don't want to have to sit in front of a breadboard and do that all by hand. I mean, eventually you will when you get to the prototyping stage, but in the design stage, you just need to know your calculations. And so this is a great way to study for all quizzes and for all tests, okay? Now, there is an alternative to this, and it is made available by the same company. So this is the much, much more powerful version of the circuit simulation because it's got all of this extra stuff that's in here, okay? If you just wanted to go down to base calculations, you can go, if you type in Multisim Live, and you go to the online simulator, it will actually produce a really pared down version of the full Multisim circuit simulation software, okay? And, when you go to the online simulator, I don't know who this person is, all right? But you could just go ahead and open up this circuit, just say open anyway. I have a login created, so I'm going to show you what you can do when you do have a login. But you can just open this one up if you just want the calculations. Okay. Now the first thing I would do when I get in here, if that's what you want to do, is I would do a Control A and then delete and just get rid of everything that's there. Okay. The other thing is that this one, if you click on that link, it automatically puts you in this split mode. So I would get rid of the split and just go to the schematic. Okay. Here's the grapher portion, and then the split is having them both on the screen at the same time. So you want to leave it on the schematic just for the components you're going to add. Okay. So that's if you just wanted to get to the simulator from just typing it into Google. Now, I have a login for this. And, whoop, there we go. The nice thing about creating a username real quick is that you can actually save all of the circuits that you build. So if you wanted to build one and then come back to it, you can save it. You can save in the full version of Multisim too, right? So you can save file, save as, and then you can save it, as whatever you want. Okay. So in here, you can see that I've got a few of these that that I've created. I usually don't save mine, but since I'm in this and now I'm logged in, I can say create circuit, and so this will automatically take me to a blank slate. Whereas if you just click the online simulator, you have to delete the stuff and then get into the right view. So this just creates a new circuit, and so now I have a blank slate here. Okay, all of the instrument stuff is over here on the left, and just a little bit different. So I want to build a similar circuit here to show you what the differences are. So the sources are all right here. Okay, and so I'm going to click that. I'm going to go over to DC voltage and place that on my schematic. Now this one doesn't automatically pop you back into the screen. You have to go choose another one. Okay, so now I'm going to go choose some resistors, and that's this fourth menu item down, the passive components. And I'm going to go ahead and add a resistor. Now, you can see here I've got 4 options when I put this on here. One is to delete it. This one is to flip it around if you want to go 180 degrees. And this one will rotate it 90 degrees in one direction. Okay, so this one I just want to make a copy because I want 2 more of these. So I'm going to click the copy and click again to paste it. Click here to copy and then click here to paste it. All right. Now because I don't have Control R like I do in the full version of Multisim, I have to come up here and select this one and then click rotate. All right. Wiring it up, same thing. It actually gives you a little spool of wire there. So you have the hand, and then you go to a junction and you can wire from it. So click, click, just like regular Multisim. Click, click, and finally make this connection. Click and click. Now I have to have a ground in this as well. So this second family down here, I'm going to go ahead and put my ground in right there. Okay, again, I could go ahead and simulate this. Click the simulator. And you see right here, it's already saying, hey, connect the probe so that you can actually see what's going on. So there it's running. Okay, and I know it's running because I see my elapsed time here, but I don't have any indicators on here. I have no meters. But let's just take a peek at what the grapher is doing right now. Well, it's not doing anything because it doesn't have any probes to look at. So let's go give it some probes. So I'm going to click stop. Now here, you don't even have the option, to my knowledge, you don't even have the option to put a meter on here. You have to use the little magic probes. So if you want to do a voltage measurement, it's a little bit different. Because you just have a single selection for both the node voltage and for component voltages. So I select this, and this one is just going to be my node voltage, so I know that I have 12 volts. Okay? And I'm going to click outside of that. Then I'm going to come back up here and grab another voltage probe, and I want to measure the voltage across this resistor. Okay? So I put this at the highest voltage potential. Now notice what happens when I place it. I have 3 choices. I can delete it, I can duplicate it or copy it, or I can place the reference probe. So now I can place it over here. Now it's acting like a multimeter, for a component voltage drop. So now I can come back up here and hit play. And now I have two things I can look at. So this is a 4-volt drop across this resistor, and this is a 12-volt node voltage, which is always referenced to ground. Okay. Now here's why why we wouldn't use the grapher, or why we don't use the oscilloscope in DC, because this is what it looks like. Okay. It doesn't do us a whole lot of good to look at an oscilloscope, which is basically, as you can see here, voltage versus time. Voltage on the y-axis and then time on the x-axis. Because in a DC circuit, the current doesn't change, the voltage drops don't change, everything is static. So there's my voltage probe for my source, and then here's the voltage, the probe that it's referencing is right here. It's actually two of them, because it's this pair that's producing this 4-volt signal here. Okay, so that's why we don't use the grapher in this portion of the class. It becomes important when you start talking about AC circuits and you have sine waves. But for DC, we just want to know the component values. So this is good enough. So I can come back up here and hit stop, come up here and grab a current now this time. And you can see it's got an arrow as well. And yeah, so there we go. So now I can come up here and say simulate, and there's my 4 milliamps. Okay. All right. And if you want to change, I'm going to go ahead and get rid of these probes so they're out of the way. Just select it and then hit the little X. Okay. If I want to change the value, it's a little bit different. You want to, instead of clicking on the symbol, which it won't let you do, it just selects the symbol when you do that. You want to click on the actual value itself. Okay. And it's got this little slider that you can move back and forth, but it's very hard to nail the exact voltage that you want. So the easiest way is just to select right here and then type it in. 9.5 volts. There we go. All right, this one, I'm going to click on the actual value. And so now this one is 2.2K. Whoops, I have to select right here. 2.2K. Whoops. This one, I select the actual value here, and I change it to 6.8K. And then this one down here will change to, how about 4.7K? There we go. Then I can throw a current probe in here. I can throw, whoops, I don't want that. I want the voltage. So maybe I measure from here to here just to check what this voltage is, and then I can simulate it. There you go. So this one has a 693 microamp current, because we got quite a bit of resistance here, at least for this smaller battery. And 4.7 volts, 4.72 volts across this component right here. All right. So hopefully that helps you with your circuit analysis techniques in terms of viewing them in the circuit simulation software. And whether you're doing it in Multisim Live or whether you're doing it in the full version of Multisim, you now have a tool that will essentially let you study for any type of circuit that you create, because you can have the answers and know that they're right essentially immediately. As long as you build the circuit correctly, you can have the answers immediately and double check yourself. So this is the greatest study tool that I know of for all of circuit analysis. Okay. All right. I think that concludes this. And make sure that you comment to let me know that you have seen this. And yeah, talk to everyone later.